group of researchers say they've identified at least 7 stars that might be surrounded by alien megastructures known as Dyson spheres.
We would call this a Dyson swarm, not a Dyson sphere, because only a swarm would stay in a stable orbit with the sphere potentially breaking apart.
For centuries we've wondered, if are we alone in this vast universe? After endless searching, we've stumbled upon something far more shocking. What if the strange heat radiating from 7 distant stars isn't natural? Could these be the first clues of alien megastructures? Colossal constructs harvesting their star's power? 7 stars, signs of alien mega machines. In the far reaches of space, 7 stars have been discovered emitting a strange kind of heat that has left scientists puzzled. Unlike the countless stars that behave as expected, these 7 radiate mid-infrared heat in ways that defy natural explanation. This has led some researchers to an extraordinary possibility. These stars might be surrounded by colossal structures built by advanced alien civilizations to capture energy. If true, it could be the first ever evidence of intelligent extraterrestrial life. The unusual heat signatures were uncovered through data collected by advanced telescopes like Gaia and WISE, which scan the universe for light and heat patterns. Amid millions of stars, these 7 stood out as anomalies. They radiate heat consistent with what would be expected if massive alien-made machines were harnessing their energy. The idea points to something potentially monumental, a civilization using its star as a vast power source through advanced technology. This concept aligns with the idea of a Dyson sphere, a hypothetical megastructure first proposed by physicist Freeman Dyson in the 60s.
This was later explored by British guy Freeman Dyson, who essentially wanted to explore this from a more scientific perspective.
A Dyson sphere, or Dyson swarm, could be constructed by an advanced civilization to encircle their star with gigantic solar collecting panels, absorbing its light to convert it into usable energy.
Could be built by advanced civilizations out there in order to harvest as much energy from the star as possible.
Such a structure would block most of the star's visible light, but would emit waste heat in the form of mid-infrared radiation, precisely the type of signal observed from these 7 stars. The discovery is remarkable because of the consistency of the findings. All 7 stars display the same peculiar heat radiation, suggesting something extraordinary and possibly artificial.
That would be able to harvest these stars' resources directly by building individual structures orbiting the star.
The fact that this pattern is repeated across multiple stars strengthens the theory that they could be surrounded by alien mega machines in various stages of construction or use. These structures, if real, would be the work of highly intelligent civilizations that have mastered the ability to control and utilize the energy of their stars. The possibility that we have detected signs of these alien structures is both awe-inspiring and humbling. If these heat signatures are indeed the result of Dyson spheres, it would mean that intelligent life not only exists elsewhere in the universe, but has also achieved a level of progress that dwarfs our own. It would confirm that we are not alone and that the universe is teeming with possibilities for life and innovation far beyond what we can currently imagine. While the exact nature of these structures cannot yet be confirmed, the evidence points to something truly extraordinary. The heat emitted by these stars is consistent with the theoretical models of how a Dyson sphere would function, releasing infrared radiation as waste heat after absorbing a star's light. This alignment between observation and theory makes the idea of alien megastructures a compelling explanation for these anomalies. The discovery of these 7 stars could mark a historic moment in the search for extraterrestrial intelligence. If further investigations confirm that the heat signatures are indeed caused by Dyson spheres or similar constructions, it would forever change our understanding of life in the universe. These stars may represent the first glimpse of civilizations that have risen to unimaginable heights, creating technologies so advanced that they have become part of the very fabric of their cosmic environment. This discovery reminds us of the vast and mysterious universe we inhabit. If these stars are evidence of alien life, they could provide answers to some of humanity's oldest questions. Are we alone? How advanced can civilizations become? The idea that other intelligent beings are out there, building colossal machines to harness the power of stars, is a profound and thrilling thought. These 7 stars, with their strange and inexplicable heat, may hold the key to uncovering the greatest mystery of all, the existence of life beyond Earth. In the vast expanse of space, where stars burn for eons without change, 7 stars have emerged as a perplexing puzzle. These stars emit a strange heat that has sparked the curiosity of scientists. At first, the unusual infrared glow sent waves of excitement through the scientific community. Could this be evidence of advanced alien civilizations constructing enormous machines to capture the energy of stars? Are we alone? The idea of extraterrestrial intelligence was thrilling, but as scientists delved deeper into the mystery, doubts began to arise. Now, the prevailing theory suggests that the strange heat may not be a sign of alien activity at all, but instead a cosmic illusion. The heat could be coming from galaxies filled with gas and dust, distorting the signals and creating a false mystery. Unlike typical stars, which follow well-established energy patterns, these 7 emitted infrared radiation that didn't match expectations. This deviation initially led some to believe that the stars might be surrounded by massive, energy-harvesting structures, perhaps the work of alien civilizations. But as further observations were made, a different, more natural explanation started to take shape.
The infrared light passes through some of the gas, revealing new details in the nebula, as well as an amazing number of stars.
Infrared radiation is notoriously difficult to study because it interacts with everything it passes through. Dust clouds, gas, and even distant galaxies can all emit their own heat or bend light in such a way that it distorts observations.
A newborn star is formed, but we can't see it until we look in infrared light.
A star's heat signature can be affected by these cosmic elements, leading scientists to misinterpret the data. If a galaxy happens to align with a star in just the right way, the overlapping signals can give the illusion of excessive heat coming from the star itself. This effect could easily trick scientists into thinking something far more extraordinary is happening than what is actually taking place.
For galaxies, visible light emphasizes the stars in the galaxy, vast clouds of gas and dust between the stars.
One potential source of the confusion is what are known as hot dog galaxies. These are galaxies filled with dust and energy, often powered by black holes at their centers. As the black holes pull in matter, they generate vast amounts of energy, heating the surrounding gas and dust to the point where it begins to glow in the infrared spectrum. This glow can be so intense that it can overpower entire galaxies, and when seen from Earth, it can blend with the heat emitted by a star in the foreground. This creates the illusion that the star itself is radiating far more heat than would be expected from a normal star. Follow-up studies of the 7 stars have uncovered evidence that hot dog galaxies are located nearby in at least 3 cases. These galaxies align perfectly with the stars, providing strong support for the idea that the detected heat is not coming from the stars themselves, but from the background galaxies. The alignment of these cosmic objects, though rare, is not impossible. The universe is filled with countless galaxies, and it is conceivable that such coincidences could occur, making it difficult to untangle the signals. The challenge of interpreting infrared radiation is further compounded by the limitations of our technology. Instruments designed to study the universe, such as space telescopes, are excellent at scanning large areas of the sky and detecting millions of stars and galaxies. However, they struggle to distinguish between objects that are closely aligned. If a faint galaxy happens to lie behind one of the 7 stars, its infrared light could mix with the star's signal, creating the illusion of an abnormal heat source. This blending of signals makes it difficult to determine the true origin of the heat and could easily lead to false conclusions. The stars themselves add yet another layer of complexity. The 7 stars in question are all red dwarfs, small, relatively dim stars that are typically stable and simple in their behavior.
70% of stars in the universe are red dwarfs. They are the tiniest stars out there, with only about 7 to 50% of the mass of our sun.
Red dwarfs are also one of our best bets to find alien life, and might be the last home of humanity before the universe becomes uninhabitable.
One of our best bets to find alien life, and might be the last home of humanity before the universe becomes uninhabitable.
Rarely have large clouds of dust or other material nearby that could cause unusual heat signatures. However, in some rare cases, remnants from a star's formation or from planetary collisions can create thin dust clouds around the star. These clouds can trap heat, which then radiates outward in the infrared spectrum. This trapped heat can mimic the signals expected from artificial structures, creating the illusion of something much more extraordinary than what is actually happening. As more data is gathered, the growing evidence suggests that natural causes are behind the strange heat signatures. Hot dog galaxies and dust clouds are the most likely sources of the mysterious heat, and the presence of these factors has already been confirmed in several cases. While the remaining stars still present some questions, many scientists believe that further research will eventually confirm similar natural explanations for the remaining anomalies. These discoveries serve as a reminder that the universe is full of complex and unpredictable phenomena, which can sometimes appear far stranger than they truly are. The notion that these stars could be evidence of advanced alien technology is a captivating idea, but the truth may be far simpler. Rather than representing a breakthrough in extraterrestrial exploration, the strange heat may be a result of the chaotic and intricate processes that govern the cosmos. The interactions between stars, gas, and galaxies create patterns that challenge our understanding and push the limits of our technology. These patterns can appear to be extraordinary, but in reality, they are just the natural consequences of the universe's complex workings. Could the strange heat from the 7 stars be a sign of alien megamachines? Or are we simply too far behind advanced civilizations to recognize their true purpose? Human on the Kardashev Scale. Humans have always looked up at the stars with wonder, imagining what lies beyond our planet. But when it comes to space technology, where do we truly stand? The Kardashev Scale, a system created by Russian scientist Nikolai Kardashev, offers a way to measure how advanced a civilization is based on its energy use and how it generates it.
Something called a Kardashev civilization, named for Nikolai Kardashev, astrophysicist.
On this scale, humanity is far behind where we should be. While we've made significant progress in space exploration, we are still a long way from mastering the universe's full potential. In fact, it's possible that other civilizations, far more advanced than us, may already control entire stars or even galaxies. The Kardashev scale is divided into 3 major types. A Type 1 civilization can harness and use all the energy available on its home planet. A Type 2 civilization can control the energy of its star, like building a Dyson sphere to capture a star's energy. A Type 3 civilization would be able to control the energy of an entire galaxy.
3 on the Kardashev scale would be you can control all the energy of all the stars in your galaxy.
Humans currently fall somewhere between Type 0 and Type 1, meaning we have barely begun to tap into the resources and energy of Earth, let alone space. To understand just how far behind we are, consider the energy demands of even basic space exploration. Today we rely on chemical rockets, which are powerful but inefficient. These rockets can only carry limited payloads and require vast amounts of fuel. NASA's Apollo missions, for example, which sent astronauts to the moon, relied on technologies developed in the 1960s. Even though these missions were groundbreaking, they were only a small step compared to what a Type 2 or Type 3 civilization might achieve. A Type 2 civilization would be able to harness the full energy of its star.
If there was a Type 2 civilization, could you detect it? What would it look like?
This might sound like science fiction, but it's a real possibility, according to theoretical physicists. One of the most well-known ideas is the Dyson sphere. If humanity could build something like this, we would have access to energy far beyond what we currently imagine. But today we can barely send probes to our neighboring planets, let alone build structures around stars. Even the energy required to send a probe to the farthest reaches of our solar system, like the Voyager spacecraft, is immense and limited. Meanwhile, civilizations on higher Kardashev scale levels would have mastered technologies that we can barely dream of. For a Type 3 civilization, the control of an entire galaxy would be possible. These civilizations might travel between stars with ease, harvest energy from black holes, or even manipulate time and space. Such control over galactic energy would allow them to create technologies that are incomprehensible to us, perhaps bending the laws of physics in ways we can only speculate about.
So if that's the case, you can think of levels of civilization based on how much energy they consume.
If we consider the possibility that extraterrestrial civilizations exist and are far more advanced than us, we must acknowledge that they could already have achieved what we can only dream about. They might already be using energy from stars, traveling between galaxies, and manipulating the very fabric of the universe. In fact, if we were to encounter such civilizations, we might be so far behind them that we would appear as primitive as cavemen are to us today. But this should not discourage us. Rather, it should serve as a reminder of the vastness of the universe and the potential of what humanity can achieve. We may not be able to control stars or galaxies yet, but with each new discovery and every technological breakthrough, we move closer to unlocking the secrets of space. Just as humanity once thought the Earth was the center of the universe, our current understanding of space may be just the beginning. The next great leap could come tomorrow or in centuries. But with determination and innovation, there's no telling how far we can go. What if the civilizations that control entire stars and galaxies are out there, waiting for us to catch up? What incredible discoveries might we uncover when we finally reach their level of technological mastery? Our journey in the stars. Humanity is on a long journey toward mastering space, but we are far from being the advanced civilization we dream of becoming. The road to reaching higher levels of technology and energy control, as imagined by the Kardashev Scale, is filled with challenges, but breakthroughs are happening, and each one brings us a little closer to our goal. While we currently struggle with the basics, the future might hold some unexpected leaps in technology that could change everything. One of the biggest challenges humanity faces is the sheer distance between stars. Even with our fastest spacecraft, such as NASA's Voyager, which has traveled far beyond the planets of our solar system, we are nowhere near capable of reaching even the closest star to our own, Alpha Centauri. It would take thousands of years to reach it with today's technology. To become a Type 1 or higher civilization on the Kardashev scale, we need to figure out how to travel vast distances at speeds much greater than we can today. Without this, our exploration of space remains limited to our own solar system. But despite all this, NASA's Voyager is a brilliant breakthrough in space tech. The Voyager 1 and 2 probes symbolize humanity's curiosity, ambition, and resilience. They captured stunning images of our solar system and sparked awe worldwide. Voyager revealed discoveries we didn't even know to look for, says project scientist Edward Stone. Their journey continues to inspire generations, pushing the limits of exploration. The second major challenge is energy. To control a star as a Type 2 civilization would, we would need to harness immense amounts of energy, far beyond what we can currently produce on Earth. We can't even build such a structure around our own planet, let alone a star. The energy required to develop the technology to make this possible is mind-blowing, and the materials needed may not even exist yet in a form that we can use. While the challenges are immense, there have been some breakthroughs in space exploration that give hope for the future. One major advancement is the development of new propulsion systems. Traditional chemical rockets have been the go-to for space missions, but they are inefficient, using up huge amounts of fuel to send small payloads into space. However, new ideas like ion propulsion and nuclear-powered engines offer much better efficiency. These systems could allow for faster travel and could one day make interstellar journeys possible. If we can develop these technologies further, they could help us reach other stars and planets in a fraction of the time it would take with current methods. Another breakthrough comes from private companies like SpaceX. Their goal to send humans to Mars and beyond is one step toward creating a more permanent human presence beyond Earth. Mars is the closest and most accessible planet for colonization, and SpaceX's Starship is designed to carry people and supplies to the Red Planet. If this technology succeeds, it could pave the way for human settlement on other planets and could help us learn how to live off Earth, one of the key steps for becoming a Type 1 civilization. Additionally, the search for new energy sources is ongoing. We currently rely on fossil fuels, but they are harmful to our planet and cannot support the needs of a growing technological civilization. Solar power, wind energy, and nuclear fusion are all seen as potential sources of energy for the future. Solar power is already used to power satellites in space, and researchers are working to improve its efficiency. If we can make solar power more effective, it could help fuel the space missions of tomorrow. Meanwhile, nuclear fusion, the process that powers the sun, holds incredible promise. If scientists can figure out how to control fusion on Earth, it could provide the near limitless energy needed to build advanced space technology. Artificial intelligence is another breakthrough that could change the future of space exploration. Artificial intelligence could help us solve complex problems related to space travel, such as navigating distant planets and stars. It could also assist in building and maintaining space stations and spacecraft. For example, artificial intelligence could be used to manage the life support systems for a crew traveling to Mars or to assist with the construction of large structures in space, such as satellites or space stations. The use of artificial intelligence in space exploration could speed up our progress by performing tasks that would take humans much longer to complete. On October 4th, 1957, Sputnik launched, marking the start of the space age. Today, new advancements in space technology, such as reusable rockets, ion propulsion, and AI-driven spacecraft, are pushing the boundaries of exploration. These innovations bring us closer to interplanetary travel, sustainable space colonies, and harnessing energy from stars. While the technology needed to become an advanced space civilization seems far off, these breakthroughs demonstrate that progress is possible. With each new discovery, humanity is taking steps closer to the goal of mastering space. The road is long, but it is filled with possibility. As we continue to push the boundaries of what is possible in space exploration, we may find ourselves making advancements that we once thought were beyond our reach. The path to becoming an advanced civilization will not be easy, and it will take time. But the challenges we face are not insurmountable. Through innovation, collaboration, and perseverance, humanity has the potential to overcome the obstacles in our way. The journey is just beginning, and the future holds endless possibilities. Thanks for watching. We appreciate your time and interest. Don't forget to like, share, and subscribe for more fascinating content. See you in the next one.